The dam did not fail in silence. Hours before midnight, a dam keeper saw muddy water coming from the western side of the St. Francis Dam. He knew enough to worry. Muddy water could mean that water was carrying the ground away from beneath the structure. William Mulholland, the most powerful water engineer in Los Angeles, came out to inspect it. He looked at the leak, studied the wet slope, and decided the dam was safe. Just before midnight on March 12, 1928, the wall disappeared. More than 12 billion gallons of water tore down San Francisco Canyon. A flood wave smashed powerhouses, worker camps, rail lines, farms, homes, and whole sections of towns. By morning, bodies and debris were washing toward the Pacific Ocean. The death toll is still uncertain, but modern accounts place it at more than 400 people. This was not simply a dam that broke. It was a warning system that broke first. To understand why, you have to start with Los Angeles and its hunger for water. In the early 20th century, the city was growing faster than its local supply. Mulholland had become famous for building the Los Angeles Aqueduct, the vast system that carried water from the Owens Valley across mountains and desert into the city. To Los Angeles, he was a builder. To many people in Owens Valley, he was the face of a water grab. Either way, his authority was enormous. The St. Francis Dam was built as a storage reservoir for that aqueduct system. It stood in San Francisco Canyon, north of Los Angeles, a narrow site that seemed useful because the canyon walls could hold back a large reservoir with a relatively compact concrete dam. Construction began in 1924. The dam was completed in 1926. It rose about 185 feet above the canyon floor and held a reservoir that could store roughly 38,000 acre-feet of water. But the canyon was not as solid as it looked. The dam rested against two very different sides of rock. One side included a reddish conglomerate that could weaken badly when saturated. The other side included ancient landslide material and fractured rock. Later investigators would argue over exactly where the first break began, but they agreed on the central point: the foundation was not suitable for the structure that had been placed on it. The warning signs began long before the final night. As the reservoir filled, cracks appeared in the concrete. Some were explained as normal temperature or contraction cracks. Seepage appeared near the abutments. Water moved through weak zones and was collected through pipes. Late in 1927, more fractures appeared near the abutments and were sealed. In February 1928, when the reservoir was nearly full, new areas of seepage appeared near the wing dike. This is the pattern that makes the disaster so chilling. Each sign could be explained away by itself. Concrete cracks. Dams seep. Hillsides get wet. Engineers make judgments. But together, the signs pointed to a structure interacting with a foundation that was changing under pressure. The final reservoir level was reached in early March. On March 7, Mulholland ordered no more water turned into the reservoir. 5 days later, dam keeper Tony Harnischfeger made his morning rounds and found a new leak on the west side. The color alarmed him. It looked muddy. He called Mulholland. Mulholland and Assistant Chief Engineer Harvey Van Norman arrived and inspected the site. They found the leak. They watched its flow. They judged that the mud was coming from loose soil near an access road rather than from the dam foundation itself. They did not order an evacuation. They did not lower the reservoir. After roughly 2 hours at the dam, they returned to Los Angeles. That decision is the heart of the story. Not because Mulholland saw the future and ignored it, but because the system depended too much on one man's confidence. There was no modern independent dam safety agency standing over the city. Municipal dams with their own engineering departments were largely outside state supervision. There was no robust emergency warning plan for the communities downstream. So the canyon went into the night with a full reservoir above it. At about 11:57 p.m., the St. Francis Dam catastrophically failed. The reservoir emptied with terrifying speed. Near the dam, the flood wave was high enough to destroy massive concrete and steel. Powerhouse number 2 was demolished, and dozens of workers and family members living nearby were killed. Downstream, the water followed the Santa Clara River Valley through Castaic Junction, Piru, Fillmore, Bardsdale, Santa Paula, and toward Ventura. Warnings came late and unevenly. Power and telephone lines failed. Some people were reached by operators, officers, and residents racing ahead of the water. Others had no chance at all. The flood arrived in darkness, carrying concrete blocks, trees, buildings, rail equipment, mud, and oil field debris. By the time it reached the coast, it had traveled more than 50 miles. The scale of the damage shocked California. The remaining center section of the dam stood like a monument to the failure, while enormous chunks of concrete lay scattered down the canyon. Photographs show twisted tracks, ripped landscapes, and the strange geometry of a dam that had seemed permanent only hours earlier. Investigators moved quickly. The governor's commission concluded that the dam failed because of defective foundations, especially weak material that lost strength when wet. A Los Angeles City Council committee reached a similar conclusion. Later engineering analysis added more detail, including the role of uplift pressure, saturated rock, and possible movement in ancient landslide material. But the public lesson was already clear. The dam had not simply encountered an unknowable act of nature. It had been built on geology that should have demanded more caution, more investigation, more drainage, more independent review, and a better emergency plan. Mulholland accepted moral responsibility. His career effectively ended. California changed its laws. In 1929, the state strengthened dam safety oversight and gave state officials authority to review and supervise many non-federal dams. The disaster also helped push the regulation of civil engineering, because the cost of informal confidence had been measured in lives. That is why St. Francis still matters. The ruins are not only the remains of concrete. They are the remains of an older way of making public risk. A great engineer could stand at a leaking dam, decide it was safe, and send a valley back to sleep. The people downstream did not get the data. They did not get a warning siren. They did not get a second opinion. The warnings were there: the unsuitable foundation, the cracks, the seepage, the near-full reservoir, the muddy leak, the absence of independent oversight, and the communities below with no reliable alarm. When the dam failed, it did so in minutes. The conditions that made it possible had been building for years. And that is the lesson written into San Francisco Canyon. Infrastructure does not only fail when concrete breaks. It fails when warning signs become routine, when authority replaces verification, and when the people in the flood path are the last to know.